guys, today we're gonna learn on how to solve a super root equation. So you know that a square root equation or a cube root or radical equation you need to like square a cube or 4/4 raise it to 4 both sides like that because exponentiation is the reverse of logarithms and roots. So let's go say square root of x equals 4. Now, now it has an index of 2. So if it has like an index of 2, that means I need to square both sides. Meaning that the 2's will cancel, giving us x by itself. 4 squared is 16. That means x equals 16 is the answer. But, however, if you put plus or minus 16, that's not, that's 50-50 correct. 1/2 correct. Correct over 2 correct. Okay. So it's correct and wrong. So here's the wrong one. X equals -16. This is the wrong one. But x equals plus or minus 16. This is the correct one, and then this is the incorrect one. Okay? So make sure you plug in, okay? Square root of 16 equals 4 because 4 squared is 16. That's true. Let's go try another one. Cube roots. The cube root of, let's go say 1000 equals what? Hold on. It should be the cube root of x equals 10. Okay, so it has an index of 3. So that means I need to cube both sides. The 3's cancel. Being leaving was x. X equals 10 cubed. It gives us 1 followed by 3 zeros. And that means x equals 1000 is correct because cube root of 1000 equals 10. Because 10 cubed is 1000. Let's go do a super root and super cube roots equation finally. So let's go say the super root, that is the nice super root. Okay, so the super root of x. Remember, there's a invisible 2 over here. That keep in mind. The square root of, the super root of x equals 2. Now, I don't want to square both sides because this is a super root. The inverse of a super root or super radical is a tetragration. So I need to tetrate both sides by 2. Remember, the invisible 2's cancel. Okay? I'm just going to put in parentheses, okay? Okay? So, the super root of x tetrated to 2, I forgot to include the s, but I assume that I included the s, okay? Let me just rewrite the parentheses. There. Okay. So, the 2's will cancel, leaving us with x by itself. 2 tetrated to 2 is 4. But I know that the super root of 4 is 2 because 2 tetrated to 2 is 4. Let's go try another example. Let's go do the super root of x. The super root of x equals 4. Now, it has invisible 2 here. So I need to tetrate both sides by 2. this is not an Ingus number over here. Okay? Okay. Now, the 2's are cancelled, giving us x by itself. Do not include the s, it's just a symbol. Now, 4 tetrated to 2, if you don't know, tetration is repeated exponentiation. So, 4 tetrated to 2 is the same as 4 raised to the 4th. This tells that the left exponent or super exponent or height tells you how many times to repeat the base number. So the base number is 4, the left exponent is 2. So if you know your exponent chart or something like that, you should know that 4 raised to the 4th power equals 256. Okay? Let's go try another one. But with super cube roots. The super cube root of, let me try to think of a number. X equals 2. Now, I don't want to tetrate both sides by 2. Instead, I want to tetrate both sides by 3 because the 3's are cancel, giving us x by itself. Okay? So, x is equal to 2 tetrated to 3. We can rewrite it as 2 squared squared, evaluated from from up to down. 2 squared is 4. 2 raised to the 4th power equals 16. And when you plug it in, the super cube root of 16 is 2 because 2 tetrated to 3 is 16. Also, we'll try another one with super fourth roots. The super fourth root of x, I couldn't think of other numbers too, because 2's is like the easiest way. So instead of tetrating both sides by 3, I need to tetrate both sides by 4 because the 4's will cancel. Now the 4's will cancel. X by itself equals, I forgot. It should be on the left. Okay. Now 2 tetrated to 4. I can rewrite it as 2 squared squared squared. And I know that this is that part in the box is equal to 2 tetrated to 3. So let's go replace that with 2 tetrated to 3. Now I know that 2 tetrated to 3 is 16. So 2 raised to 16. And whatever you can do, you can break that up into 2 raised to the 8 times 2 raised to the 8. Instead of adding the exponents, I can just replace 2 raised to the 8 with 256 and just do standard algorithm. 256 times 256 equals 65,536. So if I plug in 65,536 into the super fourth root, we see that the super fourth root of 65,536 equals 2. So that's correct. I almost said incorrect. So this is correct right here. One last one. The super fifth root of, let's go say x equals 2. Now, I gotta tetrate both sides by 5. It will cancel. That's why. Now, the 5's will cancel, giving us x by itself. X equals 2 tetrated to 5. I can rewrite it as 2 squared 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 5 times. Now, I know that this part covered in the box is 2 tetrated to 4. So let me replace that with 2 tetrated to 4. Now, according to PEMDAS, the higher priority or higher level operations must come first. So 2 raised to 4, we know that 65,536. You're wondering, like, how do we evaluate 2 raised to 65,536? Well, it's gonna have a bunch of zeros or something like that, and we don't know the value, and it's gonna take us a very long time to do that. So I'll just read it down as this. I'm pretty sure the calculators can't calculate this. Okay? So the answer is 2 raised to 65,536. So let's go plug that in. 2 raised to 65,536. Let's go do it. I know that 2 raised to 5 equals 2 raised to 65,536. And this is the correct answer. Or if you don't know 2 raised to 4, you can leave this answer as 2. This will work. I'll accept either answer. Bye guys. I hope I see you in the next video. Bye.